Question 28. Evaluate the integral of s squared cos s ds. Solution. Put u equals to x, dv equals to cos s ds. If we differentiate u, we have the u equals to 2s ds. If we integrate the v, we have v equals to sine x. The integral of s squared cos s ds will now be from the formula. We have integral of v du equals to u times v minus integral of u dv. Then we now have, you substitute v into the formula, which we now have s squared times our u is sine x minus the integral of s, the integral of u, which is s, times the differentiation of dv, which is cos s ds. Therefore, we now have s squared sine s minus the integral of s cos s ds. But we know that from the integration, s cos s ds is equal to minus s sine s plus cos s. Therefore, the integral of s squared cos s ds is equal to s squared sine s plus s sine s minus cos s plus c. Integration by partial fraction. If a rational expression is not in a standard integral form, it could be transformed into a standard form by splitting it into partial fractions. Question 29. Evaluate the integral of 3s minus 9 all over in bracket s plus 1 close bracket and open rounded bracket s minus 2 ds. Solution. First, split 3s minus 9 over in bracket s plus 1 close bracket and another bracket s minus 2 into each partial fraction. Then we have 3s minus 9 all over s plus 1 in bracket s minus 2 equals to a over s in bracket s plus 1 for the first denominator in bracket plus b over x in bracket s minus 2 for the denominator in the second bracket. Then we now find their LCM, which is s plus 1 in bracket times s minus 1 minus 2 in bracket. Then after we did our calculation, we now arrive at a over a times s in bracket s minus 2 plus b times in bracket s plus 1 all over in bracket s plus 1 over in bracket times s minus 2. Then if our 3s, the numerator from the equation, if the 3s minus 9 is equal to the numerator of the final answer of the fraction a in bracket s minus 2 plus b in bracket s plus 1. Then if we substitute or put s equals to 2, you now have 3 times 2 minus 9 is equals to a in bracket 2 minus 2 plus b in bracket 2 plus 1, which is equals to, if you do our mathematics, we now have minus 6 because 6 minus 9 will give us minus 3 is equals to 3b. Therefore, if you solve for b, we now have b is equals to minus 1. Then if you substitute s equals to minus 1 for the numerator, you will now have for the b. If you now substitute s equals to minus 1, we now have 3 times minus 1 minus 3, which is equals to a in bracket minus 1 plus b in bracket minus 1 plus 1, which we now have minus 12 is equals to minus 3a, which is equivalent to a is equals to 4. If you solve for a, we now have a to be equals to 4. Therefore, we now have 3s minus 9 all over s plus 1 in bracket and another opening of bracket s minus 2 closing the bracket is equals to, our a is 4, we now substitute, we now have 4 over s plus 1 plus our b is minus 3, we now have minus 3 over s minus 2. Therefore, we now say the integration of, therefore from the integration of 3s minus 9 all over in bracket s plus 1 times in bracket s minus 2 ds will be the integral of in bracket 4 all over in bracket s plus 1 plus minus 3 over in bracket s minus 2 close bracket ds. If you open the brackets, we now have integral of 4 over in bracket s plus 1 ds plus in bracket minus 3 over s minus 2 ds. Therefore, the integral will now become 4 in bracket s plus 1 minus 3 in bracket s minus 2 plus c. Question 30. Evaluate the integral of sine squared s cos s ds. Solution. Put u equals to sine x. The u over the s is equals to cos x. The s over the u is equals to 1 over cos x. The s is equals to the u over cos x. The integral of sine s cos s ds is equals to the integral of u cos s du over the x. Cos s will cancel cos s to leave us with the integral of u squared ds. Therefore, the integral of u squared is u raised to power 3 over 3 plus c, which is equals to sine 3s sine raised to power 3x over 3 plus c. Question 31. Evaluate the integral of cos squared s sine s ds.